Alright everybody, welcome back to another video. Today I am going to be talking about scalar line integrals. For the purpose of this video, we're going to be going through this example. Let C be the unit circle x squared plus y squared equals 1, and suppose the density of C is given by f of xy equals x squared. So, when we see density given by f of xy, we know that this is going to be some sort of scalar line integral. So let's first write out the formula for scalar line integrals. So you have, going from a to b, f of r of t multiplied by the length of the derivative of r of t times dt. This is obviously in parameterized form, but you nevertheless get the picture. If I wanted to put this in more simple form, we would have, well, our notation is as follows. Whoops. Our notation would be the integral across C, which here is the unit circle underlined. The integral across C of f of x, y, ds, where ds is the length element. Okay, so let's go ahead and compute this example. First, we are going to parameterize the curve C. So we have r of t. Whoops. R of t equals cos t sine t. Yeah, okay. So using this formula, we can now go ahead and actually compute this. So we're going to have right, so okay, so we're going to have so this is our function x squared, so we only take the x value, which is cos t. So we have cos squared t multiplied by the length of r dash t, which is, let's just do that here. Cos goes to minus sine t, sine goes to cos t, and that is with respect to t. Okay. So, okay, let's go ahead and do this. Cos squared t, and then this is just going to be sine squared t plus cos squared t, which is 1. So just cos squared t. So we're going to have the integral of cos squared t with respect to t. Oh, and sorry, I forgot to add in the bounds. They're going to be from 0 to 2 pi, because those are the bounds of the unit circle. So 0, 2 pi. Now we can rewrite cos squared t as 1 minus cos 2t. Let me just check that's correct, because let me just check that quickly. been a while since I've looked at these identities. I just want to make sure I've got that right. Sorry, bear with me. I'm just checking it now. Let's have a look. Yeah, so cos squared t, okay, is cos 2t plus 1 over 2. Okay, so sorry, this should be a plus here. Sorry about that, that's stupid of me, I should really know that, but it's always good to double check these things. Okay, so now we compute this relatively simple integral. We are going to get 1/2 t plus so that's 1/2 cos 2t, which is going to go to 1/4 sine t. Yeah, and we're gonna evaluate this from 0 to 2 pi. So we're gonna have pi, and then sine of 2 pi is just 0. So our final answer is just pi. That is our kind of our mass, right? Because the density was given here, and therefore when we add this length element, length times density is gonna give us mass. Okay? And given its length, this is obviously gonna be in, as I said, grams. Yeah, just in grams. So hopefully that made sense. It can be kind of a confusing topic, but hopefully that made a little bit of sense.